Hello, everyone, and welcome back to Automate Live. My name is Jana Martin. I'm the Media Production Manager here at the Association for Advancing Automation, the host of Automate, and I'm joined on my right by Jake Hall, the Manufacturing Millennial. Jake, so glad you're here.
It's great to be here.
And then, of course, on my left here, we've got Craig Nelson. You're the Senior Product Marketing Manager at Siemens. Thank you so much for being here today.
Thank you, Jenna.
All right. So tell us a little bit about your background in the automation industry at Siemens. How did you get here today?
Okay. Well, I'm an old drives guy. I almost said an old crusty drives guy, but so my 2 hours of online marketing and communications training really paid off. So I've been around for a while in the drives world. Goes back quite a few years. Matter of fact, I remember a little story that when I first started, I was a green guy getting my initial training on drives, and at that point, when we were tuning drives, we were soldering in resistors and capacitors to tune them. Mm-hmm. And the first digital drive showed up, and there's a sales guy, and he was a crusty old sales guy. And I remember when they auto-tuned for the first time, and he looks at us new trainees, and he's like, "I don't know why they hired you guys. We don't need you anymore." So we all got real scared that we were going to. And anyways, 35 years later, still here doing drives.
Absolutely. And and that's the one thing that Siemens has a breadth of product lines that you guys manage, but one of the specialties that you guys focus on is motion control and specifically drives. And as the industry is growing, more automation is happening, more motion control is happening, which kind of leads into new technology that's being pushed between AC and DC drives. So I guess my first question that I have is, when manufacturers are focusing on optimizing and creating, effective solutions when it comes to adding more drives to systems, how do they go about maintaining that? Like, where do they start that process?
Well, I mean, that's the big picture here at Automate. We're just seeing such an explosion of automation being added to manufacturing. And everybody's adding additional lines, they're adding additional robots, everybody's putting more smart conveyors, and everything is just becoming more automated.
Yeah.
And with that increased levels of automation that we're doing, this means that they're adding a lot of new drive systems and drives to the thing. The other half of that is now we got to provide power for all of this automation, and drives consume a lot of power. It's just what they do. They do a lot of work, they use a lot of power. Majority of power being used in most manufacturings are around drives. So efficiency of drive systems has really become a key topic.
Absolutely. I remember going to jobs and you'd walk into, and there, you would have 20 or 30 different MCC rooms, master control, that would just be focused on all the drive management throughout these facilities. And it's a big part of manufacturing facilities. I don't think a lot of people even realize the impact that it has.
True. And again, just growing at just a tremendous rate.
Let's switch over and talk about like DC bus. Mm-hmm. How can implementation of a common DC bus architecture contribute to optimizing power efficiency across multiple drives on the plant floor?
Well, there's been a big emergence of DC power lately. And it's funny because for about 20 years, it was always getting away from DC and going from AC. And now with the new innovations happening, renewables happening, DC's becoming a big part of the plant again. A lot of plants are actually even integrating in a local DC grid into their power plant. So not having to do all those power conversions, and seeing that they're using maybe renewables or they have batteries. If they're trying to do power shaving, or peak power shaving, where they want to store up energy so they don't have to use the peak power, kind of brings it down to a more moderate and sustainable power system. You're seeing a lot more DC being integrated into plants. Along the drive systems as well. I mean, using a common DC bus on AC drive systems is not new, but it's really seeing a renewal now, and the fact that that's a very efficient way to utilize your drive power. So if you have a common DC bus, you might have axes that are generating where other axes are motoring.
Yeah.
So being able to recover that energy instead of wasting it away to a braking resistor has become a tremendous asset.
What do you think the biggest drive to that's going to be in terms, like drive, no pun intended, but like why are manufacturers pushing that direction?
I wouldn't say so much manufacturers are pushing that direction. Having a drive system that is off the shelf that can do a common DC bus system, I think that is really probably leading to, if you want to call it the push from the drive suppliers.
Yes.
But the end users, I believe, and OEMs, really to meet their efficiency standards or to become more efficient, that's really where the pull is coming from.
Okay.
And what are some of the considerations that should be taken into account when considering this technology?
Well, that's another good point. It's not like we're just going to connect everything across DC or all your drives in your whole plant. If you want to connect them all to DC, that doesn't really work out. These have to be designed to operate on a common DC bus. So, looking at that, I would say one of your things you need to look for when you do this and try to optimize your power efficiency and you use a common DC bus is that the equipment that you're putting on this DC bus is designed for this.
Mm-hmm.
So, you have to take into considerations, you put one of those devices on the DC bus, it could be a large inrush, and how much current that they are capable of being connected to or their bus is rated for. Those need to be taken into consideration.
Needs to be a part of that original plan.
Yeah, it's better to do it from a greenfield drive system, but a lot of times you do have capabilities of adapting, or if you're adding additional axes to a line, it might be part of a retrofit that you say, okay, we want to increase the efficiency and we have a lot of regenerative power that we can accommodate for. Let's go ahead and make this increase in efficiency.
So do you see a lot of this solution coming in from retrofitting at brownfield facilities, or do you see a lot of this just being pushed through greenfield, brand new facilities?
More from the greenfield, I expect. You can do it, it just takes twice the amount of work if you do it from the brownfield versus the greenfield, unless it was already previously designed for that or you're expanding on that. A lot of modular drive systems that can connect on the DC bus. That's another point where you can, as you expand, you can add these onto the DC bus. And again, it really is an efficient way to have a multi-axis drive system implemented.
So what would you say is changing? We talked about driving efficiencies through a common DC bus structure, but let's move into, the world of servos. How are you able to drive power efficiency through servos? Like, what does that process look like?
Yeah, well, a servo drive system is a really efficient drive system. Basically on the servo motor. It gives us a high efficiency standards just in the nature of it. But you're seeing servos being used, for one example, to replace hydraulics. So you're seeing a lot of, whether it be just the hydraulics or a servo or a hydraulic press, being replaced by a servo.
Because of the high torque needs, right? Or is there other reasons for it?
It's high torque, but high efficiency as well.
Okay.
If you have hydraulic running, it's basically running on an across-the-line motor to make sure you have that hydraulic pressure all the time. With servo, instantly, it can make that pressure. So it can be in a standby mode, using little to no energy, and then when the demand occurs, it can provide that high torque capability. And you don't have all the additional noise of hydraulics and cleanup of hydraulics versus a cleaner servo solution, more sustainable.
So when companies are looking at this direction and they're looking at, hey, here's my roadmap, I want to be able to push a certain strategy around this technology, where do they focus when it comes to optimizing what they want to do on the plant floor?
I guess really it depends on the application.
Can you give us an example?
Well, I was thinking, if you start off just from, let's say, a single drive running a fan or a pump, we know a lot of technologies are, moving from across the line to a VFD.
Yeah.
But then when we're on the VFD side of it, there's a lot of new, moving to a synchronous reluctance motor, which is really high efficiency. Another example of that might be also using being able to go into a sleep mode or a standby mode when it's not used. But there's a lot of new logarithms how we control the motor in the drive, and those are becoming a lot more efficient. And basically, only providing the exact power required is a big increase in efficiency.
Absolutely. Okay.
Let's jump over and talk about digital drivetrain, digital twins. What role do these technologies play, such as digital twins and condition monitoring, play in optimizing, that power efficiency within the drive systems? Can you explain that a little bit?
Yeah, that's a big question and a big topic. If we look at the digital drivetrain or the digital thread out there, what we're doing and just with the digital twin concept and the whole digital thread concept is everything from the start. So when we're going in and we're designing, let's say a machine, for example, and we're doing the design of it, having these simulation capabilities that we can do.
Right.
So the selection becomes a lot more optimized. And that's one thing with drives and motors. A lot of times they get oversized. So having these more simulation capabilities to right size the motor and drive, that's a big increase in efficiency instead of the whole lifetime of the drive system being oversized. Then we go into the next phase of it, and then we're going ahead and we're installing it and we're commissioning the drive and drive system. Again, we'll use the simulation capabilities. We'll use a lot of additional just methods where we can go in and now make the drive become a sensor. And from that, all that information, so it just becomes transparent. Having the motor become a sensor and transparently getting all that information back, whether it be the edge to the cloud.
Yeah.
Then we can do all the data analytics. Then with all the data analytics, again, that just goes into a whole time of saying, all right, let's go ahead and, making sure that's right size for the next generation. Let's also take into account as well, we can look at efficiency, and use condition monitoring, so predictive maintenance schedules. All of that can really be done at a level we really haven't even thought of. So that data analytics, that condition monitoring is really taking off and is another aspect of the whole digitalization concept.
Yeah, absolutely. I remember at a previous job, there was a job where we replaced close to 1,200 drives on a single site because of just moving efficiency, but also giving a much better understanding of what was happening and upgrading on a protocol. It was a big step. So I guess, moving into kind of the last question, what would you say some of the biggest misconceptions around when you're wanting companies to look at moving to this type of technology from the topics that we talked about, either it's through digital twins, if it's through a DC bus architecture, if it's through pushing efficiency through servo drives? What would you say is the biggest challenge that you run into when you're trying to get customers to move to this type of solution?
At the engineering resources.
Okay.
Right now, I think that's a challenge for everyone. So efficiency and engineering, from the selection to the commissioning to the complete life cycle. I think that's where we're really seeing a different set of efficiency when we talk about engineering efficiency and ease of use.
Yeah.
You're just seeing such dramatic increases in the ease of use throughout the whole life cycle of drive systems today.
So how do companies then go in and then create either an ally with the company internally or an ally with a manufacturer on bringing that forward? Like, how do they champion that process and that change?
And I think a lot of times when they integrate in with a solution provider or an OEM that really is trying to drive sustainability or efficiency, when we take a look at our machine designs or what's the requirement for a new machine, really adding in some efficiency considerations, I think, is a big point here.
All right, one more question from me. When you look into the future at Siemens in your role, where do you see this drive technology going? What are you excited about?
So a lot of new things happening, the advances in integrated safety. Security is another thing that I think is going to just be a big topic that everyone's going to have to step back and think about. So from the drive and motor being really almost a sensor component, being able to add that cybersecurity, just another layer starting from the sensor, I think that's where you're going to see a big jump in the near future.
Yeah.
That's awesome. All right, well, this has been so fun talking about drives today here at Automate Live with Craig Nelson, the Senior Product Marketing Manager at Siemens. Thank you so much for joining Jake and I today.
Thanks, Jenna. Thanks, Jake. That was very exciting.
Absolutely. We'll see you guys soon.